Honeycomb in concrete, concrete defects, concrete vibration, concrete compaction, concrete repair, structural integrity, concrete quality control, air pockets in concrete, voided concrete, concrete failure, bug holes, concrete construction, how to vibrate concrete, concrete mix design, formwork leakage, engineered voids voiceover script. You're inspecting a newly stripped concrete column, and you see it a rough, rocky surface with pockets of aggregate exposed and paste missing. It looks like a honeycomb, and your heart sinks. This isn't just an aesthetic issue, it's a glaring red flag for compromised structural integrity. But in another context, you might hear about honeycomb systems being intentionally designed into concrete to make it lighter. So, which is it? A catastrophic failure or an innovative technique? In this video, we're clearing up the confusion once and for all. We'll dive deep into the unwanted honeycomb defect, its root causes, how to prevent it, and the right way to repair it. Then, we'll briefly touch on the engineered systems that use the same name for a completely different purpose. By the end, you'll be able to diagnose the cause of honeycombing on your site instantly, and implement the practices that ensure dense, durable, and high-quality concrete every single time. Let's start with the bad one, unintended honeycombing. This is a surface and internal defect characterized by a rough, stony texture with voids and cavities between the coarse aggregate particles, the cement paste that should envelop and bind the aggregate has failed to fill the spaces, leaving the aggregate exposed. This happens for one fundamental reason: the concrete was not properly compacted to achieve full consolidation. Think of fresh concrete as a complex mixture of ingredients. The vibration from a poker vibrator does two critical things. It pushes the aggregate particles closer together, expelling trapped air, and it liquefies the cement paste, allowing it to flow into all the spaces between the reinforcement and the formwork. When this doesn't happen completely, or voids get trapped, creating the honeycomb structure, the consequences are severe. Honeycomb concrete has a much lower load-bearing capacity. As the effective cross-sectional area is reduced, it exposes the reinforcement to air, moisture, and chlorides, leading to rapid corrosion. It creates a pathway for water ingress, leading to freeze-thaw damage and further deterioration. A pro tip from site engineers is that honeycombing often occurs in congested reinforcement zones if the vibrator head cannot be inserted and moved freely through the rebar cage. Honeycombing is almost guaranteed behind the bars. So, what are the specific causes? We can break them down into three main categories. First, and most common, is improper vibration. This includes not vibrating enough, vibrating too much, which causes segregation, using a vibrator with the wrong frequency or diameter for the formwork, or simply missing sections altogether. The second major cause is issues with the concrete mix design. A mix that is too stiff or has poor workability. A low slump is difficult to compact, especially around tight reinforcement. A poorly graded aggregate with too many large, jagged pieces can also lock together and prevent consolidation. The third category is handling and placement errors. Dropping concrete from excessive heights causes the aggregate to segregate from the paste. Leaky formwork that allows cement paste to seep out will leave behind a rocky, honeycombed surface. A common and catastrophic on-site mistake is to add water to the truck on-site to improve workability without adjusting the mix design. This increases the water-cement ratio, weakening the final strength, and can exacerbate segregation, making the problem worse in congested areas. Now, let's talk about the solution, which is always better than the cure. Prevention is absolutely key. It begins during the mix design phase by ensuring the concrete has adequate workability and a well-graded aggregate for the specific placement conditions. On site, the golden rule is proper vibration. The vibrator should be inserted rapidly into the concrete, held for typically 5 to 15 seconds until the air bubbles stop rising and a glistening film of paste appears on the surface, and then withdrawn slowly. The insertion points should be spaced about 1.5 times the radius of influence of the vibrator to ensure full coverage. Furthermore, you must ensure your formwork is watertight and that the concrete is placed in layers, not in a single massive dump. A pro tip for deep elements is to use a trendy pipe to place concrete. which prevents segregation during a long drop. But what if you've already found honeycombing? The repair process is methodical. First, the affected area must be assessed by a structural engineer. Then, the repair begins by removing all loose and weak concrete, often using a small jackhammer or scabler, until you reach sound, solid material. The next critical step is to clean the exposed reinforcement bars of all rust using a wire brush. Then, the surface must be cleaned of all dust and debris. The key to a successful repair is the bonding agent, a slurry of cement or a specialized epoxy brushed onto the prepared surface just before the repair material is applied. The repair material itself is typically a non-shrink, high-strength grout or patching mortar, packed in tightly in layers. The final surface can then be finished to match the surrounding concrete. It's worth noting that honeycomb can also refer to intentional void-forming systems. These are not defects, but engineered plastic forms, often in a geometric honeycomb pattern, that are tied down to the decking before the concrete pour. Their purpose is to create voids within large concrete slabs, reducing the dead weight and the amount of concrete used while maintaining the structural depth and strength. This is common in long-span floor systems. The crucial difference is that these are planned, controlled, and designed, whereas the honeycombing defect is a random, uncontrolled result of poor construction practice. To summarize the key takeaways: 1. Unintended honeycombing is a serious defect caused by poor compaction, a bad mix, or placement errors. 2. It severely compromises strength and durability by exposing reinforcement. 3. Prevention through proper vibration and mix design is non-negotiable. And 4. Repairs must be engineered and methodical to restore structural integrity. Now I want to hear from you. In the comments below, what has been your biggest challenge in achieving perfect concrete consolidation? Was it incredibly congested rebar, a tricky mix design, or training a crew on proper vibration techniques? Your real-world experience is the best teacher. If this guide to understanding and defeating honeycombing has been valuable, please give this video a like and subscribe.